Question 17, okay, cyclists A and B leave the same spot for rest and travel in opposite directions. Cyclist A accelerates at 0.5 meters per second, while cyclist B accelerates at 1 meters per second squared. How far apart will they be after 10 seconds? Now, you can do this two ways. The first way is you set up two different data sets, and then you calculate the individual times after 10 seconds. The quick way of doing it is relative motion. Does anyone remember how to do relative motion? You basically combine both their accelerations and both their speeds together, okay? So they're both traveling from rest. 1 second. So guys, while you're waiting on me, okay lads, so have here's your UVAS system, and on your UVAS system we're going to have a U equals 0. Now acceleration A, one of them accelerates 0.5 to the left, the other one accelerates 1 to the right. In total, if I was to hold one of them stationary, every second they're separated by 1.5 meters per second acceleration, because that's one, it's going left and the right. So you add them together to make a combined acceleration of 1.5 meters per second. Okay, the S we don't know. We know that T equals 10. So we have U, A and T. So our best option for our distance would be UT plus a half AT squared. So UT plus a half AT squared. Okay, put it in and we're going to get S equals 0 plus a half 1.5 multiplied by 10 squared, 75 meters apart after 10 seconds. Do knowledge. Okay, so this is question. Yeah, 75 meters, okay? Now, let's move on to part 2. Part 2, I'm going to keep the same system, except this time, same system, except the time is different, okay? So the time is different this time, but we know that the distance will be 108. 108. Okay, so once again we're going to use UT plus a half AT squared. Then we're going to find out what T is using a quadratic. So it's still going to be 0. And then it's going to be a half 1.5 times T squared. I do actually know what the S value is. The S value is going to be 108, and then we're going to have 0.75 T squared equals 108. Now, I'm going to take a guess that 108 divided by 0.75 is more than likely 144. Yeah. They always tend to give you nice numbers, so divide by 0.75 into that, and it's going to be 144. T equals 12 seconds. They're actually not that hard, really. Once you do the relative step at the start, where you combine them together, they're actually quite easy. What's your other option for doing these? Two systems. You could do two systems, and you could have like you could have an S1 and an S2, and what you'd have to say is that S1 plus S2 is 108, and you'd combine them both sets together, and you'd have to do UT plus a half AT squared twice. Add them together and then do a quadratic equaling to 108. Takes a lot longer, right? Not worth the time. Now, moving on. Okay, the maximum acceleration of a body is 4 meters per second, and its maximum retardation, which means deceleration, is 8 meters per second. What is the shortest time in which the body can travel a distance of 1,200 meters from rest to rest? So that's very similar to what we had yesterday, isn't it? The what goes up must come down. You just go You just accelerate all the way up. Can anybody describe the shape here? What way should the second triangle be? And much deeper. Half the size, but really like, there's not a triangle there. Just dropping down half the size, okay? Now, we understand that because of the acceleration difference, what do we already know? This one covers twice the distance of that one. It's going to be 800 and 400. We can do that right away, but we really want to back up our maths and be able to do that, okay, so to understand it. So what we say is the ratio of T1 to T2 is the same ratio as deceleration to acceleration, which is 8 to 4, which is 2 to 1. Okay, so this means that T1 is twice as long as T2. So let's call that 2T and T. Call the maximum distance there the velocity V. You have two triangles, triangle A and triangle B. So a half the area of triangle A, or sorry, a half is the area of triangle A. So the area of triangle A plus the area of triangle B will equal 1,200. And then what we can find out here is a formula that's for, so it's going to be 3 over 2 VT equals 1,200. Okay, now guys, we have two variables. Anybody tell me how do I get rid of one of these variables? Or we need another equation. Anybody know where the other equation comes from? Huh? Acceleration or deceleration. If I say acceleration is always tan of your angle in these questions. So acceleration is tan x. Tan x in turn is phi over 2t. Phi over 2t in turn equals the acceleration of 4. This means that first of all, we're looking for shortest time. What does that mean? We should get phi in terms of t. So phi equals at. We're going to substitute that at into this formula here for phi. Okay, so it's going to be just do it in red here. Segment this. So it's going to be 3 over 2 multiplied by v. V is at. Multiplied by another t. That equals 1,200. So cancels to come 4. 3 times 4, 12. 12 into 1,200 is 100. T squared equals 100. T therefore equals 10. Okay. What you should do sometimes when you're doing these type of questions is really easy, like something like you might have done a couple of years ago in primary school. I'm just going to draw a picture of what's going on here. I'll represent Alberto here is going to be in red. Gustav is going to be in green. Now the problem is Gustav was in the lead. Gustav and Alberto here. Now Gustav was in the lead, but what's going to happen is he's had a puncture and he's just after getting going again. Then Alberto is going to eventually overtake him. And we can say that this is this point here where he overtake. If you look at Gustav's acceleration, he has a larger acceleration than Alberto. So eventually he's going to take over again. So Alberto is using his superior speed at the moment and still accelerating, and then eventually Gustav will catch him up, and then there'll be another point down the road where Gustav then overtakes Alberto. Okay? So you can do two separate ways of doing this, okay? So the first way would be to say that, look, Alberto's data set, and then this is Gustav's data set. Okay, so what's Gustav's data set at the moment? Just call Gustav is starting from rest. His final velocity we don't know. His acceleration 2. His distance, haven't got a clue. His time, haven't got a clue. So, but what we do know is that we'll just call it S. Okay, his distance can be S. Then we're going to look at Alberto's time. U, V, A, S, T. Alberto is travelling at 12, accelerating at 1. His S, now, he has to catch up with Gustav. So what does that mean? He has to cover the same distance as Gustav, which is S. But he also has to cover 22 more to make this happen. Time is the same variable. Okay? Now, if I do ut plus a half at squared here for Gustav, so s equals ut plus a half at squared, what happens here is we're going to have 0, and then we're going to have a half. We're going to have a half times 2 times t squared. So it's just going to be t squared. Is that correct? Yeah, S is t squared. Okay? We do the same thing for Alberto, and we're going to get s plus 22. Ends up to be ut, which is going to be 12t, plus a half times 1 times t squared. And then we're just going to get 12t plus 0.5 t squared. Now, this s here can be substituted for t squared. So we'll just say that's t squared. Then we can move the 0.5 and the 12t over the other side. So we're going to get minus 0.5 t squared minus 12t plus 22 equals 0. We're going to get 0.5 t squared minus 12t plus 22 equals 0. We're going to multiply that by 2 to get t squared minus 24t plus 44. That's a very easy question. Then we're going to get a t into so t minus, sorry, what's it going to be? Minus 22 minus 2. Now guys, what you notice about both time answers, they're both eligible, aren't they? Because they're both positive. So the first one occurs after 2 seconds. He passes them out after 2 seconds. Then they pass each other out again after 22. But the question is, after how long more will Gustav overtake Alberto again? 20 seconds more. Because you have to take the two of them away from each other. That's it. Looks like a very tricky question, but ain't too bad at all. You could also do it using relative, where you combine both data sets together. Do you want me to combine the data sets together and do it that way as well? Yeah. Okay. Okay, so what we're doing next is we're going to combine the data sets and see if there's any way we can use them to do this question. Okay, so you're going to have one data set, and now it's very important to decide which one of the guys you're comparing it to. So I'll show you what I mean by that. Okay, so this is Gustav and Alberto's now, okay? So, like last time, we're going to take it from, whose perspective shall we take it from? We're going to take it from Alberto's perspective, okay? And what I mean by Alberto's perspective is we're going to basically treat Gustav like he's stationary. So Gustav is treated like he's stationary. Now, do you know what I mean by treating somebody like they're stationary? What I mean is this: if I was running after somebody and I'm running 10 meters per second and the person I'm chasing is running 5 meters per second, what I mean by taking it from my perspective is that if I hold this person stationary, relatively speaking, I'm actually only catching up I'm actually only going 5 meters per second after that person, because they're running in the same direction I am. For example, if that was 3 meters per second, I'd be catching them up by 7. If we're going in the opposite directions, you add them together, okay? So what we're going to do is something very similar to that. It's a much simplified version of what we're doing. So what we're going to do is we're going to Gustav is treated like he's stationary, okay? So Alberto still has to cover 22 meters. They have to make up, between the two of them, he has to make up 22 meters, okay? His U value, anybody know what Gustav's U value is? Well, he's moving at 12, Alberto's not moving at all, so still 12, right? Now the accelerations are different. The acceleration is Gustav's accelerating at 1, Alberto's accelerating at 2. Well, but that's going to be more or less like A. It's going to be a deceleration though, isn't it? Because he's losing. See the way this one's going 2 and this one's going 1. The acceleration of Gustav is greater than Alberto, so that means he's almost getting slower in comparison to Gustav. If somebody accelerates faster than you, okay, you'll see the difference in your speeds eventually close until they pass you out or until they go faster than you and pull away into the distance. So relatively speaking, he's experiencing a deceleration of -1. Okay? Then your time is still exactly as it was. We're going to do S equals UT plus a half AT squared. So it's going to be UT plus a half AT squared. So it's going to be 12T plus, so that's going to be minus, because that's going to be -1, minus a half T squared. That equals 22, right? Bring everything over one side, we have a half T squared minus 12T plus 22. Multiply everything by 2. That's exactly the same formula we got last time, isn't it? Except it's a hell of a lot quicker. We didn't have to substitute anything in. Okay? So it's just thinking about your accelerations relative to each other. Somebody accelerating faster than you, where your basically your speed relative to them is going to, if you're already going faster than them, they're going to appear to be getting faster. Okay? If you're going at the same speed, you'll just see him just go off into the distance with this superior acceleration. Okay? Alright guys, moving on. Any questions on that one? Okay. Number 23 next. A passenger train which is travelling at 80 meters per second is 1500 meters behind a goods train which is travelling at 30 meters per second in the same direction on the same track. What rate must the passenger train decelerate to avoid the crash? This is an interesting one. Crash avoidance. Okay, so we'll have once again, draw your picture. Red train can be the passenger train. Goods train is going to be, we'll put them on slightly separate tracks at the moment. Now, the thing is, there's no acceleration, is there not? So they're traveling at constant velocity, yeah? Now, just to avoid the crash. Now, what you could say is that, like, this question is slightly ambiguous because you'd surely say, well, the maximum deceleration possible. Like, there's no reason why you can't stop, like, I don't know, 500 meters away from the goods train. That's not even an issue. I think what the question is meant to be doing is it's meant to be asking you what's the minimum deceleration you need to apply, just basically so you're basically just right behind the goods train, but not clashing. Okay? So, with that in mind, what we're going to do is we're going to set up our, I suppose what we can do is we can combine both of them together. U, V, A, S, T, U, V, A, S, T. Now, this one here, called the goods train. Goods train's 30 its end velocity is 30, its A value is 0, its S value, the goods train is still moving while all this is ongoing. So the goods train we'll call S, we'll call the time T. What about the passenger train? Starts at 80. What does the end velocity of the passenger train need to be to avoid a collision? 30. Because the minute you're going 30, you no longer catch them up again. It doesn't need to be 0. The biggest mistake in leaving cert would be putting that as a 0. Okay? It's A, we don't know. We'll just call it A. It's S. No, the S value is important. Anybody know? S plus 1500. And then T value the same. Now, we can see what we're doing here, can't we? UT plus a half AT squared per volume. We seem to be always going to this formula at the moment. Okay, and then UT plus half AT squared. So it's just going to be the first one, which is the green one. This is going to be equal to just 30t, isn't it? Because a half of 0 gets you nothing. So the distance for it's just distance by time, or sorry, speed by time, 30 by t. Okay, and the other one is going to be 80t. 80t. Now this one's interesting, right? Because we're going to have 80t plus a half AT squared. Now, can anybody tell me what's the problem at the moment? Anybody know the problem?
We don't know that any is 0.
I have too many variables. Now, I have a choice. My choice is two things. I can use V equals U plus AT, and then I can do, what's that going to be? That's going to be 30 equals 80 plus AT, then it's going to be minus 50, isn't it? Now, are they looking at, they're looking for me to find the deceleration, yeah? So, what I do is I get minus 50 equals AT. Now, do I get rid of T, or do I get rid of A? I'm going to get rid of A, and then I'm going to find what T is. Once I find out what T is, I'll find out what A is, right? So it's not a big deal. So, A equals minus 50 over T. Now you modify your current equation. So it's going to be 80T plus a half of minus 50 over T by T squared. So it's going to be 80T, what's that? It's going to be minus 25T, isn't it? That T cancels with that one there and gives you minus 25T. So that is going to be 55T. So S2 equals, oh, one other thing, that's not S, is it? It's S plus 1,500. So S plus 1,500. So S plus 1,500 equals 55T. Now, we know that S on its own is 30T. Will somebody divide 1500 by 25 for me? That's where we're going with this. Bring the 30 over to your side. We're going to get 1500 equals 25T. T equals? What'd you say?
60.
60. Okay, now lads, 60 seconds. Therefore, what's the deceleration? 50 over 60, which is minus 5 over 6. Is that the answer in the solutions? Background, yeah? Okay.